everyone, my name is Jiaman. Today I will talk about one of the most important wireless communication technology, which is the low complexity detection in massive MIMO system. On the above, I like to thank my supervisor, Dr. Chenhua Guo, for his guidance and constant encouragement. For this presentation, there are mainly 5 parts. Firstly, I will give you a brief introduction about my project, including the motivation, the basic concepts, and the problems in massive MIMO, and also the aim of my project. Next, I will introduce the detection technology. In this part, there are 3 detectors covered, which are zero forcing, linear minimum mean square error, and maximal ratio combining. Then, I will talk about the simulation process I made to evaluate the performance of the 3 detectors. Finally, in the last part, I will conclude my presentation. Let's move on the first part. Currently, in our daily life, mobile devices have become more and more important tools. With smartphones, you can watch video online, talk to friends online, or even have a meeting online. We cannot live a day without mobile devices. But with growing number of users, the data transmitted on these devices is increasingly sharply. Based on Cisco's report, the mobile data traffic has a growing trend, and also people tend to expect a higher transmission rate and reliability. However, technically, this spectrum used for wireless communication is limited. So we need novel technology to solve all these problems, which in the massive MIMO system. So what is a massive MIMO system? Basically, MIMO system is a system that allows multiple input and output at both transmitter and receiver sides. With such a system, you can use multiple antennas transmitting data simultaneously, exponentially increase the capacity of wireless channel. Besides, you can also improve the spectral efficiency, and the most important thing is you don't need any extra bandwidth. However, there are still some problems in this powerful technology. When the system is working, as you can see in the picture, a receiver will receive data from different sources. Besides, the data needed, unexpected data, can also be received, which may cause interference and increase the bit error rate. So here comes the problem. How could we recover the transmit signal? And this is what I'm working on. In my project, I will focus on massive MIMO system and investigate several detection methods. Based on this, I want to find a low complexity but high performance detection method to recover signals. For doing this, I firstly built a mathematical model for massive MIMO system. As you can see, the system with n transmitter antenna and n receiver antennas can be modeled as y equal to h times s plus n. And specifically for the relay feeding massive MIMO system, the channel matrix can be written as this equation, which has a dimension of n times m Next, I found 3 detectors, which are zero forcing, linear minimum mean square error, and maximal ratio combining. The recovered signal can be represented using these 3 equations respectively, and they are very useful in the following simulation part. Let's move on to the next slide. The simulation process is showing you this flow chart. The detailed steps cite initial value, generate transmit signal, determine the range of SNR, generate the symbol, use QPSK, and build relay channel matrix H, generate the white noise, and get receive signal Y, and also use the detection algorithm to recover the original transmit signal. Finally, we will count the bit error rate. We will count the bit error and calculate the bit error rate. Then it is the simulation result in MIMO system with 5 transmit antennas and 5 receive antennas. The figure in the left compares the performance of ZF and LMMSE algorithm. It is obvious that the LMMSE algorithm is better than ZF since it gives a lower bit error rate. On the other hand, you can see from the figure in the right, the performance of MRC algorithm is in the same condition really disappoint us with about 10% of bit error rate. In the 100 times 100 massive MIMO system, the performance of ZF algorithm and MRC is the same as that in 5 times 5 MIMO system. Well, the performance of LMMSE improved a lot when increase the number of antennas. However, when keep the transmit antenna numbers to 5 and change receive antenna numbers to 50, the performance of MRC algorithm improved significantly, but still worse than ZF and LMMSE. To be summarized, the ZF algorithm leads to large detection error since noise effect is amplified. LMMSE detection method performs best in eliminating both channel interference and noise in massive MIMO system. The performance of MRC algorithm improves significantly when the number of receive antennas increase. Finally, let me conclude about the main content about today's presentation. Massive MIMO technologies can improve channel transmission rate, capacity, and reliability, but this system also require advanced detection technology. For current stage, the detection technology limits the prevalence of massive MIMO system. This project is important and necessary, which clarifies the advantage of massive MIMO system and compare performance of various detection algorithms. From the simulation result, we confirm that LMMSE performance best among ZF, LMMSE, and MRC. Alright, this is all for today's presentation. Thanks for listening.